The problem states a ball is released from the bottom of an elevator which is traveling upward with a velocity of 6 feet per second. If the ball strikes the bottom of the elevator shaft in 3 seconds, determine the height of the elevator from the bottom of the shaft at the instant the ball is released. Also find the velocity of the ball when it strikes the bottom of the shaft. So let's draw a diagram for what's happening here. So we're in an elevator and uh, we're traveling upwards with a speed of 6 feet per second. So that's 6 feet per second. During um, this travel, we let go of a ball, which will have a trajectory that follows this path that I'm about to draw with a continuous line. So it goes up, 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 and once it reaches the top, it goes down, 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 and down, and it reaches the bottom of the elevator shaft, which we will show as the ground. And let's show this height with this h, so this indicates one thing we're calculating because it says determine the height of the elevator from the bottom of the shaft, as well as we will also be calculating the velocity of the ball during collision with the floor. All right, so before we solve this, we might want to start by writing out the information we have. So starting out with, let's see, we say the velocity, vertical velocity, is initially 6 feet per second. And we denote this with a v naught, indicating initial velocity. We also know that the amount of time it takes for the ball to hit the ground is 3 seconds. Furthermore, the delta y, the displacement, is negative h. So what else do we know? We know that the ball experiences constant acceleration. This means that we can use one of our kinematics equations that are applicable in cases of constant acceleration. This equation is the following. So we have y, which is the vertical position at the point of interest, equals y naught, which is the position that we see initially, plus v naught, initial velocity, times t, time at point of interest, plus 1/2 times ac, which is constant acceleration, times t squared. Now, with the information we have, it is sort of clear what each of these terms equal. Our y value is equal to 0, assuming we take, if we were to draw x and y coordinates, and if we drew them like this, then our y value, which is our point of interest when we hit the ground, would be equal to 0, and our y naught would be equal to h, plus our v naught, given here, is 6 times 3, which is the value of t, plus 1/2. Acceleration is, so this is important, we're working in feet. So the value of g, which is our constant acceleration, is equivalent to 32.2 feet per second squared. So let's plug that in there. So that's 32.2 times, oh, I forgot the squared on there. I thought I wrote it, but squared. And then we have the t squared, which is going to be 9, because 3 squared. When we solve this, we get the value of h as 127 feet. This is a pretty simple algebraic equation, so I don't feel the need to do the algebra here. It would just make the video much longer than it needs to be. All right, so now that we've got that, we now move on to the second part of the question, which says, find the velocity of the ball when it strikes the bottom of the shaft. In this case, we can use another very simple kinematics equation that applies in the case of constant acceleration. And that equation is velocity at point of interest is equivalent to initial velocity plus constant acceleration times t. Now, in this equation, what we're interested in is the value of v, because that will be the value of velocity at the point of collision. So that will give us v equals, we know the initial velocity is 6 feet per second. A sub c, which is our constant acceleration. Oh, one correction to what I just wrote. The value of g here that I forgot to add. So here's the thing. This has a negative sign. So maybe I should have solved the algebra, but the 32.2 has a negative sign in front of it because the acceleration is a vector and it acts downward in the negative direction. We defined our axes here as positive y pointing upwards. So this was a silly mistake on my end, but this term is supposed to have a negative sign because our v naught, our a sub c, our y naught, all these values are assigned values. Because if the acceleration was not pointing downwards, if gravity was not pointing downwards, but it was pointing upwards, then we would have a different value for h here, and it would be a wrong value. But anyway, moving on, we have a sub c here. Again, the sign of our g is negative because it's pointing downwards. So that's going to be 32.2 times the value of t, which is simply 3. When we solve this expression, we get that velocity is equivalent to negative 90.6 feet per second. Again, the sign of this indicates that the velocity is pointing downwards, so it has a direction. And pretty much these two answers conclude the question, and have a nice day.